Okay, so today I want us to continue revising our physics paper for science paper 1. So in the previous lecture, we did, which question did we do? We did this question here. I hope you received the video for this. I think I remember sending it where we were able to, discuss some of the differences between mass and weight, etc. So our main focus, did you receive this video, right?
Yes.
All right, so make sure you just keep on revising these videos. So today I want us to do 3 questions under this paper. We're going to do question B3, B4, and B5, I think. So B3, B4, and B5. Then after we do these 3 questions, I want you to I'll also send you this paper. I want you to revise them immediately after I send them. So the first question here, question B3, is on pulley systems. And pulley systems are sometimes synonymous with gear systems. So you have something that sort of has strings and it's pushing, and you have an effort over here pulling this load connected by 2 pulley systems. So if I were to draw this diagram properly, let me just explain a little bit on how this system works. So every time you see a pulley system, just know there will be a question on mechanical advantage, velocity ratio, as well as efficiency of the pulley system. So practically a pulley, this type of pulley, the name is known as the block and tackle pulley. So this pulley system here, okay, is called the block and tally pulley. Can I write this? So block and tackle pulley, pulley type of system. So it has got 2 types of pulleys. The first one is fixed there. So the first pulley is going to be fixed using a support. So this part here is known as the fixed upper part pulley, because here it's mounted to a support. And then we've got another pulley system here that is suspended by a certain number of ropes. Well, with this type of pulley, it's a 2 pulley system because there's a rope here that's supporting this lower movable pulley, and the other one that goes directly like that. So these are the 2 ropes that are supporting this lower part. So this is the movable lower part, or the movable lower pulley. And this usually attaches a load there, like so. So this string here moving like that, and we have an effort pulling us down here. So that's the effort. So practically, this is how a pulley system works. And if you count the number of pulleys here, we've got 1 pulley there and we've got 2 pulleys. So we can call this a 2 pulley system. So looking at this question here, question 1, it says below shows a pulley system. And you have to be careful, especially when a question says state. Every time a question says state, it means you are not doing any kind of calculations. You just have to make a conclusion of the answer based on the diagram that has been given above. So here the question, using this pulley system, they're saying state the velocity ratio of the pulley system shown above. So to find the velocity ratio, so here the velocity ratio can actually be defined as the number of ropes, supporting this lower pulley system or this lower block. So this can be called a block. So lower block, upper block, or lower pulley or upper pulley. So if you want to find the velocity ratio. You can define it in two types of ways. You can say, so here we're trying to make a definition for velocity ratio. You can just say velocity ratio is the number of ropes, supporting the lower block, number of ropes supporting the lower block, or the number of pulleys, whichever one is easier. I think the number of pulleys is easier, but I'll show you in both cases, or the number of pulleys. So here, this is the lower block, like I said, and this is a pulley system. So here you can say your velocity ratio, you just count your number of pulleys based off the second definition. So I've got one pulley there, the round thing, that's one, and the other thing there, two. So you can just say, all right, my velocity ratio is 2. That's easy, right? Or you can say that, all right, this is the lower pulley, and this lower pulley here is being supported by these 2 ropes. There's a rope there, and there's another rope there. And by the way, because this lower pulley that's carrying this load there is being supported by these 2 ropes, there will always be tension in these strings. I'll come back to that. So tension 1 and tension 2. So you can actually say that, all right, the velocity ratio is also the number of strings that are supporting this lower pulley. And you can see that there's one rope here and there's one rope here. There are 2 ropes that are supporting this pulley system. And you can say, all right, my velocity ratio is 2. So remember, we're just stating, we're not defining. So the velocity ratio is the number of ropes supporting the lower block, or you can just simply count the number of pulleys. So at times, maybe this year, they might actually give you a 3-pulley system. So they might actually extend this. So this would be the upper block, and they'll actually put maybe some ropes there and attach it to a lower pulley that's attached to a load. And you can see that, all right, this is a 3-pulley system, meaning the velocity ratio is going to be 3. Or you can just count, so you can say number of ropes supporting this lower pulley, that would be 1 rope there, 2, and the one that's connecting to the pulley that's above. So the velocity ratio for a 3-pulley system would be 3. Velocity ratio for a 4-pulley system would be 4, and so forth. So be very careful. When a question says states, do not start calculating anything. Just observe the diagram and just try to find the answer from there. And since here we're trying to calculate the number of the velocity ratio in a 2-pulley system, so you just say your velocity ratio is 2. Is that okay? Have you understood that so far?
Yes.
All right. So now they won't be so easy, because the next thing that they are going to want you to do is now calculate. And every time, like I told you in physics, you have to know the principle that you are supposed to use, as well as the formula that you're supposed to use. If you forget the principle that you're supposed to use, worse off, if you also forget the formula, you're not going to get anything correct. So let's read this question. This question is now saying if the efficiency of the pulley system is 75%, remembering that a percentage is a number over 100, so we have to divide this 75% by 100 at some point. So if the efficiency of the pulley system is 75%, what is the mechanical advantage of this pulley? So as usual, there's a formula which states efficiency denoted by this fancy looking small letter n. So efficiency n is equivalent to mechanical advantage over the velocity ratio. So this is the formula that we're supposed to use. So given this formula, all we have to do is just make mechanical advantage the subject of the formula. So what do? We're going to make this small letter n a fraction over 1. Then we'll be able to cross multiply. Upon cross multiplication, we're going to end up with an equation which states mechanical advantage is the efficiency multiplied by the velocity ratio. So this is the formula that we're going to use after changing the subject. So the efficiency has been stated in 75%. So that's 75 over 100. And we're multiplying by this velocity ratio that we stated, which is 2. So all we have to do here now is just simple arithmetic. So if you go to your calculator and say 75 divided by 100, you're going to get 0.75. Then if you multiply 0.75 by 2, you're going to get your mechanical advantage as 1.5. So again, make sure once I send you this video and the past paper, just try to revise it and just try to know how to solve the answer, because the principle itself is not going to change. They are just going to maybe make a new diagram, but the method used to get to the answer will be exactly the same. So where are we here? So question C is now telling us that if the load is 120 newtons, what is the size of the effort? So if the load is 120 newtons, what is the size of the effort? So we do know that mechanical advantage is load over the effort. Mechanical advantage is the load over the effort. However, remember I did tell you that we're going to come back to the tension. So we have to find the relationship between the load and the effort. So we're not going to use this formula per se. But again, we do know that mechanical advantage, the definition of mechanical advantage is the load over the effort. But here we're trying to find, oh, but anyway, wait, maybe we can use this just out of curiosity. What is the size of the effort? So given mechanical advantage as 1.5, there's another way that I want to show you. So let's substitute mechanical advantage as 1.5. And we know the load as 120 newtons. And we're trying to find the size of the effort E. So let's cross multiply and say effort is 120 divided by 1.5. Let me see if I'll get the same answer. Hundred and 20 divided by 1.5. Oh yeah, this is the, oh yes, this is the actual equation that we're supposed to use. So mechanical advantage is equal to load over effort. Let me explain it now. This is a better method than the one that I had used. So the formula that we're going to use here is mechanical advantage, MA, is equal to the load over the effort. Now that we have got two parameters here, we have got the mechanical advantage that we just calculated. So the mechanical advantage, if we collect the data, is 1.5. The load we've been given in the diagram there, that's the load. The load is 120 newtons. So we'll say the load is 120. And what do we want to find? What is the size of the effort? So I want to know the size of the effort. So we're trying to calculate this here, the size of the effort, which we do not know. So there's a relationship. Remember, the formula that we're supposed to use is a mechanical advantage is equal to load over effort. So again, all we have to do here is make effort the subject of the formula. So this is where physics actually turns into mathematics. So let's actually make effort the subject of the formula in this space here, and then we substitute. So mechanical advantage is load over effort. We make mechanical advantage the subject of the formula and cross multiply. We're going to end up with effort multiplied by mechanical advantage is equivalent to the load. Then we divide both sides by mechanical advantage over mechanical advantage. Then effort, because this is going to cancel, effort will be load over mechanical advantage. So we're going to utilize this formula over here. We're going to say effort will be the ratio of the load over the mechanical advantage. So the load we have in the question, it's 120 newtons. So we're going to say 120 divided by the mechanical advantage, which is 1.5 newtons. So if we divide that, our effort will be 120 divided by 1.5. 120 divided by 1.5, the effort is 80 newtons. 80 newtons, like that. Once we finish this, I'm going to go through the entire question again so that you understand things properly. So that's our C part. This usually has a D part question, all right? So the D part is now saying, this question was a bit tricky. So what work is done by the effort if the load is lifted 0.5 meters? So here you've noticed they have added a distance. And you know we have got a pulley system like that. So this pulley system here that's being supported by these two strings with the effort there of 80 newtons. So I've got an effort of 80 newtons, and this 80 newtons is being used to push a 120 newton load. So this pulley system actually works on the principle that a small amount of effort can actually be used to pull a heavier load, let's say 120 newtons, using these two pulley systems. So every time you are given a distance, so the distance that has been given here is 0.5 meters. Every time you are using, every time you've been given a distance and you're moving upwards against gravity, that's work done against gravity. So what do we call work done against gravity? We call work done against gravity potential energy. So here they are actually telling us to calculate the potential energy. Again, we have a formula to calculate potential energy. So we have to say potential energy, PE, is mass times gravity times height. We do have all these three variables except from the mass. So mass, gravitational field strength on Earth, we use it as 10. And then the height is 0.5. So the only thing that we do not have here is mass, but we do have this 120 Newton force. This 120 Newtons represents the weight. So physics, unfortunately, physics is about dimensional analysis. So you have to know how you can go from weight to mass. So how can we go from the weight of an object to mass of an object? We have to use this formula, which is the definition of weight. So weight is the force of gravity acting on an object. Therefore, weight is mass times gravity. So weight is mg. So let me not write it with this multiplication symbol, but let me just say weight is mass times gravity. So if I want to know the mass, all I have to do is just divide both sides by gravity. Therefore, my mass will be the weight over gravitational field strength. The weight we've been given, which is 120, and the gravity we always calculate it as 10. So if we divide both, we cancel out the zeros, our mass will be 12 kg. So all we have to do now is just substitute where there is mass, we put 12 kg. So our potential energy will be mass, which is 12, times gravity, which is 10, multiplied by the distance that we've been given, which is 0.5. So that will be equal to, so remember potential energy is in joules. So we say 12 multiplied by 10 multiplied by 0.5, which will be 60 joules. So that's the work that has been done against gravity. So this is how you handle a question on pulleys. So let me just go back and revise the entire question so that you find it easier for your revision purposes. So here we say that, so we're now revising the question. We say that we have a pulley system here. So this is a two pulley system because you're actually seeing this upper part fixed pulley and this lower part fixed pulley. And the first question was saying we have to state the velocity ratio. Every time a question says state velocity ratio, it means we're not calculating. So because this is a two pulley system, velocity ratio can actually be defined as the number of pulleys that you have, which is 2, or the number of ropes that are supporting this lower movable fixed pulley. And there are 2. There's 1, there's 2. There are 2 ropes there, there's 1 rope there, and there are 2 ropes. There are 2 pulleys, there's 1 pulley there, and there is another pulley there. So we say 2 pulleys. Therefore, our velocity ratio, we calculated it as 2. And then the B part of the question went forward and told us, if the efficiency of this pulley is 75%, calculate the mechanical advantage of the pulley. So we have this formula which says efficiency is equivalent to the mechanical advantage over velocity ratio. So all we had to do here was make the mechanical advantage the subject of the formula here. What we did, we made this efficiency a fraction over 1 and we cross-multiplied. Then we're left with mechanical advantage is equal to the efficiency multiplied by the velocity ratio. The efficiency we've been given as 75%. By definition, a percentage is any number divided by 100. So instead of saying 75%, we say 75 over 100, multiplied by the velocity ratio, which we stated, because there are 2 pulleys, which is 2. So it became 75 divided by 100 multiplied by 2. Our mechanical advantage became 1.5. Then the question says, question C, if the load is 120 newtons, what is the size of the effort? We have a relationship here which says mechanical advantage is load over effort. I think we calculated it here. So we did say that mechanical advantage is load over effort. So once more, we have to do algebraic manipulation where we actually have to make this effort the subject of the formula. So how did we do that? We cross-multiplied and we ended up with effort multiplied by mechanical advantage is equal to the load. We divided both sides by mechanical advantage and this equation resulted here. Effort is load over mechanical advantage. The load we've been given as 120 and the mechanical advantage, we calculated it as 1.5. So here we just do simple arithmetic. We divide the 120 by 1.5. Our effort became 80 newtons. And then the final part of the question here, we're being told to calculate the work done by the effort if it's lifted at 0.5 meters. Remember, as this effort is pulling down there is work done against gravity. And we define work done against gravity as potential energy. So we need 3 variables there. calculate potential energy, we have to know the mass of the object, we have to know the gravity, and we have to know the height. So we do have these two variables. We have the gravity, because gravity here on Earth is fixed. And for easy calculation, we just take it as 10. And we've been given the height here as 0.5. So all we have to do is know the mass. But how do we know the mass? We have the weight here, which is 120. We can convert this weight to mass using this formula, which is the actual definition of weight. Weight is the force of gravity acting on an object. Therefore, weight is mass times gravity. So if we simply divide both sides by gravity, we can make mass the subject of the formula. So we divide both sides there. Mass is equivalent to weight over the gravity. The weight is this 120 newtons divided by this gravity of 10. Our mass is 12 kg. So we just substitute. Potential energy is mass times gravity times height. So it became 12 multiplied by 10 multiplied by 0.5. We get our answer of potential energy as 60 joules. This is physics, baby. You really have to know the principles. Immediately you know the type of principle that question wants you to deal with, everything else becomes easy. So just identify the principle and just keep on practicing. Don't worry, I'll be there to help you work out through all these questions properly. So you don't have to worry. Is that all right? I know that was a handful, but you just watch the video. Are you okay up to this point?
Yes.
All right. Sorry about science. Science is, yeah, science is science. Science is a handful. But all you have to do is just, unfortunately, you just have to study and know these principles properly. Okay, so let's look at question B4, which is on waves. Okay, so let's read this question together. So it says waves travel at a speed of 30 meters per second through a medium. If waves pass through a point, if 10 waves pass through a point per second, calculate the frequency of the wave. So we have to calculate the frequency of the wave. So I'm not, so every time you see a question like that where you have got speed and frequency, then it means at some point of the question, you're going to use this equation. Velocity is equal to the frequency denoted by this small letter f multiplied by the wavelength denoted by this symbol here, which is known as lambda. So if you look at this question here, they are saying 10 waves pass through a point per second. 10 waves per second. By definition, and I hope I'm right here. By definition, this word here, frequency. Oh, we're running out of time. Okay, zoom also. So by definition, frequency, this word here, frequency, is, if you run out of minutes, I'll just send you a new link. So by definition, frequency is the number of complete waves per second. The number of complete waves. The number of complete waves per second. So this is the actual definition of frequency. And if you look at this here, they are saying 10 waves per second. And when they say 10 waves per second, I suppose they mean all these 10 waves are actually complete. So just based on definition here, there is actually no need for calculation. The frequency is actually 10 Hz, just based on the definition. Frequency is defined as the number of complete waves per second. Therefore, the frequency is 10 Hz, unless otherwise. So at least this one was easy and straightforward. Then the next part of the question is telling us to calculate the wavelength. Given frequency, given frequency has 10 Hz and velocity as 30 meters per second. Remember, I told you, whether you like it or not, every time you're dealing with waves, you're going to find this question here. This equation, velocity is frequency multiplied by the wavelength, which is denoted by the symbol lambda. So again, math comes through. You have to make wavelength the subject of the formula. So we divide both sides by frequency. The frequency will cancel. Wavelength or lambda will be velocity over frequency. The velocity we've been given as 30 meters per second, and the frequency we just calculated it as 10 Hz. Okay, we just calculated it as 10 Hz. So we divide that, our wavelength will be 3 meters. So it's actually the wavelength is, if that's a complete wave, so that's a wavelength. That's the wavelength there. The distance between these two crests becomes the wavelength. So the distance between these two crests is 3 meters. So how did we do that? We use this equation here. Velocity is equal to frequency times wavelength, denoted by this symbol lambda. Therefore, if we make wavelength the subject of the formula, wavelength is going to be frequency, velocity over frequency, which is 30 divided by 10, which will be 3 meters. And then I think we can finish. We're remaining with 6 minutes. So I'm going to try to, the third question isn't that hard. So here we're saying, what does loudness of sound depend on? So the loudness of sound depends on the amplitude of the wave, which is the maximum displacement of the wave from its starting position. So this is the amplitude. So if we have a sound wave like that, the higher the amplitude, the higher the sound of the wave. But just in case, you have to know two things. So the sound, the loudness, sorry. So the loudness depends on the amplitude. But there's also in sound, there's also something known as the pitch. So the pitch of sound depends on the frequency of the wave. So that's the frequency of the wave. So take note of this. So in the next 5 minutes, let me attempt to answer this question in a way that you're going to understand it, because it's easy. Then I send the video so that you start the revision process. As usual, I have the class at 17, and I want these videos to not be so long so that I can give you enough time to go through the video and study. So this question is on light. It may look complicated, but it's actually easy. So below shows a ray of light moving from one medium to another. And there's one clue there. You can actually see that it's bending towards the normal. So this is your normal line there. So that's the normal line there. And this angle here, this ray is known as the incident ray. So incident ray. Therefore, this 50 degrees there is the angle of incidence. And then this ray here is the refracted ray. Since this is the refracted ray, this angle here is known as the angle of refraction. So they're now saying here, they are saying find this angle of refraction. So this normal here, this normal line is always going to meet this surface of this medium at a 90-degree angle. So in actual fact, this whole angle here is 90 degrees. Therefore, the angle of refraction would be 90 degrees minus 25 degrees. If we subtract off minus 65 degrees, sorry, so this angle is 65. So 90 degrees minus 65 degrees. So this entire angle is 90 degrees. So 90 degrees minus this 65 degrees, we'll be able to find this angle here, which is the angle of refraction. So our angle of refraction will be 90 degrees minus 65 degrees, which will be 25 degrees. Then the question now says we have to calculate refractive index. There's a formula. Refractive index is the sine of the angle of incidence divided by the sine of the angle of refraction. We do know this, the angle of incidence and refraction, so we have to say sine. Angle of incidence is it's 50 degrees, this one there from the incident ray, and the angle of refraction is 25 degrees. Where am I? Is 25 degrees. So this, okay. So this will be sine 50 divided by sine 25. So if you look at your calculator, sine 50 will be 0.7660 divided by sine 25, which will be 0.4226. I have to talk to Charity about your calculator situation. So the refractive index, if you calculate that, it will be 1.8. And when they are saying which medium, which of the two mediums is denser, where you have got the smaller angle, that's where the denser medium is. So the refracted ray is smaller because it's bending towards the normal like that. So that's the normal, we're bending towards the normal, meaning actually it means this medium is denser. If the angle was away from the normal, it means this medium was actually denser. But since it's bending towards the normal, the denser medium is medium B. So we're going to say medium B. So this question was actually very simple because we are just using one formula for calculating refractive index, which is Snell's law. Refractive index is sine of angle of incidence over sine of angle of refraction. So let me just send you this video in the next 10 minutes before my 17-hour class. And please practice this immediately when I send you the question. I will see you tomorrow for, is it math or chemistry?
Math.
Math, right? All right, we'll do statistics tomorrow. All right, see you tomorrow.